Yeah. Hi everyone. A very warm welcome to you all. So I'm here to explain what actually are technologies. There are many videos, tutorials, and blog spots of how technologies works, how to code, how to program. But here I'm going to explain what actually the technologies are. I'm here to answer the question for what and why. I won't be able to I'll not be concentrating on the answers of the question how, but I'll be more concentrating and briefing about the answer for what and also why to some extent. So basically, what actually are the technologies? So in a very short answer, in a very brief answer, there's nothing but a utility of the known objects. The term science means to know. We say science and technologies, right? So the science means to know the object, to know the object of knowing. So that is science. The object of knowing may be anything. It might be a grammar, it might be a person, it may be a laptop, or whatever it is, whatever the interest of knowing. But the application of those knowledge to our day-to-day life, or the utility of the objects, it's just utility. So in a sense, if a person knows how to use that one, that is enough for a technology. So he need not be able to know to the fundamental level. So that fundamental level is what the consists of the question what. But how refers actually to technologies, but what is the fundamental question of science, while how refers to only technologies. So coming to going forward, it will be more clear, I think. So in the modern days, we use binary number system for computers, computronics, and all those things. So before going further of what the technology and how does it work, let's consider some basics of binary system. So binary system as it's a famous number system. So it's a mathematical system of numbers. For example, every number can be expressed in the binary system. Binary system is nothing but a base 2 system. It consists of only zeros and ones. For example, if I consider the number 17, I can convert it into a basic base 2 system by dividing it by 2 and obtaining the remainder as 0110, and by use of this arrow I can equivalent the decimal system which is in the base 10 to the 10001 which is in the base 2 system. Similarly, I can convert the base 2 system to our convenient decimal system by the multiplication process. So this is about mathematics. So how can it be in computer, like in a computer world? So 1 represents the electron presence of electron, and 0 represents the absence of electrons in the computers. So what are actually electrons? By the standard model of particle physics, this is just a known current standard model of particle physics, where every objects or every materials which are made up of the fundamental particles has been marked or has been mapped in a table, just like periodic table. In chemistry we have a standard model of particle physics in this domain, where the basic fundamental building blocks of matter are mapped accordingly. So electrons falls into a class of particles known as leptons. So here is the electron. So okay, fine, let it be here till here. So electrons is particles in the lepton, in a lepton category. So current is nothing but, or electricity is nothing but a flow of electrons. That's all. Electricity is nothing but a flow of electrons. So 1 represents the presence of electron at a time, and 0 represents the absence of electrons at a time. So this represents the flow of current. This is the voltage, and this is time. So at what time the electron is absent, that is called as 0. At what time the electron is present, that interval is called as 1. So this sequence is nothing but a binary system in the computronics which we have used. So not only numbers, all characters, including the special characters, numbers, alphabets of different languages are marked, has been given a specific value of binary system, so that the computer can understand. Please note that computer can only understand 0 or 1, and 1 represents conveniently 1 represents the presence of electrons, while 0 represents the absence of electrons. That's it. So their sequence gives the whole output. So sequence of this one. So 17 has a unique system in a base 2 system. So that gives the sequence gives the output. Okay, fine. So now we'll enter to computer languages. What are computer languages? See, as the computer can understand only zeros and ones, we have to give the instructions or commands for the computational process in that languages only. We cannot tell a person, we cannot talk to a person with an unknown language, right? So computer language is an art. I have mentioned here art because languages, the communication varies from person to person, right? The same applies to here also. Computer languages is an art of giving set of instructions or commands. So the set of instructions given to a computer is called the software. So software is nothing but a set of all programs, and programs are nothing but the set of all instructions. So the art of giving that to a computer to perform the computational process is called the software programming or the software programming. The languages which we use might be Java, Python, JavaScript, C, C++, or Ruby, or whatever it is. So what we do in this Java or any languages is that we use convenient English language itself. For example, int I is equal to 1, or let that is in Java, and let I is equal to 1 2 3 4 in JS, or whatever it is, whatever the languages we use. So what we type in English alphabets, that is understand by us. So we can only understand English language and other native languages, but computer can understand only zeros and ones. So what we should do, we should use like translator. So the translator is nothing but a compilation, so that whatever the code which we write, whatever the program which we write, will be translated to zeros and ones, so that the machine can understand, compute, and provide the output to us respectively. So what is how is it works? So we have ASCII and UTF-8. The UTF-8 has been come recently, so we have ASCII code. So for example, ASCII value of the alphabet A is 65, and the corresponding binary value is this one, so and so. We have different and better convenient system for UTF-8. So let's not go to deeper level of that, because that's a different part of the story. I mean, that is entirely different things. So ASCII, so every character has a unique value, and that value is taken as a logical convenient value for the further computational process. So the respective sequence performs the respective operations. Yeah, as I told, this is a sequence of numbers, right? So this sequence has we'll store this symbol. So this is a symbol. Please note that I use the symbol instead of alphabet here, because this number is assigned to this symbol, so that we can read A. We cannot read this number and treat it as A or whatever. No, human cannot do that. Only but computer cannot understand this symbol. So we have assigned this sequence of character, I mean this sequence, to the symbol A, so that we can understand this symbol and the computer understand this symbol. So so that's how it works. But how do compiler actually converts to binary? See, we use transistors for that. Please note that I'm here going like briefly, very briefly, to understand better. So fine, okay, how do compiler actually converts them to binary? Please note that in whatever the mobile or CPU which we use, the transistor are the basic components of any or every electronic gadgets. So transistors arranged in a sequence are the building blocks of gates. For example, if we take any phone, there will be around like 2 billion transistors. Imagine 2 billion transistors in a single phone. So that performs a huge operations. So yeah, okay, fine. So those transistors are the building blocks of gates. So we have basic gates like in electronics called AND, OR, and NOT gates. Those are nothing but like logical operations which we have given. So those gates are built using the transistors. So what are those gates? Those gates perform the basic operations like OR, and like if any one of the input is 1, the whole output will become 1 in case of OR gate, just as in we use in our native languages or English languages OR. And the logical AND operation, if all the inputs matches, then then only the output becomes 1, or the respective output just we use in our native language or English language, and not is just a complementary. Please note that whatever we use in a convenient, whatever we use in our day-to-day life, are the same logic is used in the computers too. The only thing is that we use we use translator for to convert our languages to their language. That's the only difference. So it's a good to know this analogy. So yeah, gates, as I told, that gates are used in flip-flop also. So this can be used in a particular sequence or particular order, or that can be rearranged to form a memory element called flip-flops. So flip-flops are the electronic circuits which can hold a bit of memory. Yeah, that's a different section to cover. So please note that those flip-flop are the memory elements. So using those things, we can convert any character to a binary. So for example, we can use transistors as a switch, and also transistor as an amplification. So amplification is also a different section. Let's concentrate on basic working. I'll not be going in depth of how a transistor works, how a flip-flop works, but I'm here to explain the basic idea of the whole process. So transistor is also used as a switch. So a switch has only two states, on and off. So because a transistor can be used as a switch in a very efficient manner, whatever the inputs we are giving will be converted to 1010 or 001 in a particular sequence based on the transistor of open circuit or closed circuit. So if the transistor is in on state, then that will be then can be taken as 1, or if the transistor is in off state based on the forward bias or reverse bias, that can be taken as 0, and hence the sequence continues. So from that we can obtain the 1010 like in a base 2 system, so that the system can understand that. Yeah, before going to this one, please note that, yeah, here please see this one. So output is here 1 because the current is flowing, output is here 0 because current is not flowing. So this is the basic idea behind every computational processes, whether it may be AI, ML, or basic C Sharp, or .NET or Java, or whatever it is. So here this is the basic output characteristics of this one transistor. So okay, fine. So yeah, for example, in this image we see I is equal to I plus j. Here this is the languages which human can understand. This is a language where human can understand. Here, okay. So this is the assembly level languages. Okay, fine. This is the machine level languages where this is composed of all 1010 every basic system. So this script is the only thing which computer can understand, and this script is the only thing which human can understand. This is the assembly level languages. Even like whatever we type, whatever we type in the terminal will be converted to assembly level languages, and that assembly level languages will be converted to machine level languages. So this process will be done using the transistor, as I mentioned before. So this is nothing but assembly level languages, which is a mediator just to understand. So how does this work? For example, we have heard of tokens, right? So for example, if we take C languages, there are C tokens. So if I consider here int I is equal int I, so the int will be so every part will be broken. Int is a token, okay, I is another thing one, and equal is another token. So everything will be broken into respective blocks, and those blocks will be again will be mapped in a hierarchy. So in that hierarchy, again the compiler, the system takes the system maps the already pre-assigned base value system to the respective mapped tokens, and then the whatever the value which will be assigned will be obtained from the mathematical conversion will be assigned to those variables. and hence the whole script will be converted in this base 2 form. So after performing the operation on, we have binary operations, we have boolean operations in the computational process. So after all those operations, the output will be again converted to decimal system where human can understand, or in the English level languages where human can understand, and that will be shown. So how that will be shown? Again, we use electrons, a beam of electrons to display the output. For example, oscilloscope where the signals are being seen, best seen in the medical cases. There also a beam of electrons will be bombarded. So the sequence of beams or the respective frequency will give the respective output. So here also, the whatever the monitor we are seeing as output are nothing but electrons, whose energy, like electrons when bombarded to the screen, the energy will be transmitted out of it via photons or light. So that light having a particular frequency will be taken as input from our eyes, and the brain recognize it. So that what happens. So we can observe those things in image also. So this is a black and white image. So this image when enlarged or when went to a deeper level, we can see 1010 here. So even in the MATLAB, for example, MATLAB is a matrix laboratory. So if image when enlarged, we can see the respective numbers here, and when these respective numbers are enlarged, we can see the respective values, and those values will be again will be stored in the form of base 2 system. So this is how the system actually works. So this is how the conversion of from different mathematical forms take place. So this is how we can see the output. So that is for the software part or computer part. What about the manufacturing then? Even manufacturing is also a technology. We have aerospace, we have marine engineering, we have awesome and amazing things in the manufacturing and hardware process also. So how manufacturing is also can be can be taken into in the same context. See, even every manufacturing needs a design. So whatever the tools, whatever the machines which we do has a design. For example, this is a blueprint and blueprint and idea and design of a small bow and arrow. There are different types of bows, right? Long bow, crossbow. Even Leonardo da Vinci has had designed like a crossbow, if I'm not wrong. So so even every part or every tool which we use in our day-to-day life has a design. Those have some data or information. So how does that work? We embed, the we means human or design, embed our input, our thoughts. The thoughts are our specification. For example, if I take an example of bow and arrow, when I pull the bow, I mean when I place the arrow on the bow and pull the string, so that tension which is given to the string is like a specification. It's the input. It's the data which we transfer from our mind to the bow. For example, if we aim at a target and pull the string, so that is an data, or that is a specification. Even specification is a data. So that is the information which we transfer from our mind to the hardware object. So that is a process. That is a specification, and pulling the thread to make the tension is a procedure. And we use the correct materials, right? So we cannot use any iron or uranium to make a bow and arrow. No, we can't. So we have to use the perfect substances for that. So that may be taken as a syntax, as in the case of programming. So we cannot type the code as we want. There is some specific syntax. So here also in manufacturing also there are some perfectly suited materials. So when all these are combined, we get the output. We shoot at the target. So that's what happens. So if simple bow and arrow has this much, and imagine a big space shuttle, how complex it would be. And this one, what I have told, is nothing but like it's in a flute. It's a musical, right? So flute is an amazing instrument, and my favorite instrument too. So this is that is also, this flute is this a mixture of acoustics, or the wave physics of waves or vibrations, and the hardware manufacturing, and the user and how the user uses. So for example, flute has to be this much long. It should be made of high quality wood, and it should have a specific hole and specific number of holes with required diameters of the specific length of the flute, and there are some specifications too. And yeah, when blown the flute at a respective or a respective manner, the unique frequency of the waves pops out. So that's the melody from obtained from the wind and the vibration or the disturbance made by the user with the wind, so that the specific melody comes out, the specific ragas comes out. How beautiful it is. So what actually then manufacturing is in a nutshell? So data stored in a form of geometry. So a flute should be only in a cylinder shape, right? Should be like almost in a cylinder shape. A flute cannot be in a spear shape. No, it's not possible. So even in aircraft, it should be in a specific way to correspond to overcome the drag, to maintain the aerodynamics. So it cannot be any circular or cylinder like that. No, whatever the data, whatever the specification which the user want, he's been stored in the respective materials in the form of geometry. The shape makes the shape rules in the world of manufacturing. So that's what I'm trying to tell here. So what are the basic principles then? See, software uses binary systems. Software which has the basement on electronics. I mean, electronics is the basement. So what are electronics based on? It is based on the movement and behavior of electrons. Newly emerging, I don't know about a future of this. Photonics is. They say some experts believe photonics would be the future. So photonics is again based on the light or photons or movement of photons. So we have photomechanics also, optomechanics also. Okay, fine. Let's not worry about it and hope for good. So this is about the electronics and software industry. What about the manufacturing? Basic mechanics and thermodynamics, mostly physics and geometry. That's what the manufacturing rules on. What about civil? Civil is again a mechanics, and it deals with stress and strain. How much stress can a building hold? How much stress? How much force can a bridge hold? So those things comes here. And aeronautics, yeah, it's one of my favorite branch in engineering. So it is again based on the shape of aerofoil shape, which creates the lift. And again, the fuel used is again a chemistry. So it's a blend of those pure and natural sciences. What about anti-gravity? Well, anti-gravity, yeah, some say it's an alien technology, but I don't believe it because it has been already mentioned in the Mahabharata, and I think if I'm not wrong, even NASA is researching on that. And if I'm not wrong, even TR3B, Tactical Reconnaissance 3B, is one of the developing aircraft on working on the anti-gravity. So what does it do? It again, it's a, when come to basics foundation level, it should counteract with the already existing gravitational force. That's all. This is the basic principle. So etc. Again, this holds for not only for aeronautics, or all the branches of engineering. So this engineering is, it cannot be independent, right? So it is dependent on the pure science, for example pure physics or chemistry or biology or mathematics or psychology or whatever it is. So there exists a predefined raw material. How? For example, to make a transistor, to make a yeah here to make a transistor, we must use silicon or germanium, we must use semiconductor. We cannot use uranium to make a transistor, right? We cannot use plutonium to make transistors. No. So there exists always a predefined raw material. So how predefined by whom? So there all the characteristics, for example here, as I told, in this particle physics, a standard model for particle physics, this includes all the known fundamental particles of matter. So every particle has its own data, its own behavior. So that has to be defined, right? So every system or every process or every behavior should be defined by a definer. So yeah. So there has to be predefined raw material or predefined data or predefined information on which we human use our intelligence to build or to discover specific the specific new way of living using the available objects. So there's nothing but engineering, and it's nothing but a rearrangement of existing materials, existing data in a specific manner, so that it is more user friendly, it is more convenient to society, and it is more eco friendly. So that's what I'm trying to tell here. So coming to this one, so everything is data. For example, whatever we store, what as I told, aeronautics is see, for example, if we consider the yeah, if we consider the communication, electronic communication, it's just nothing but a transfer of data using electromagnetic waves, mostly radio waves. So what about aeronautics then? Aeronautics is again a transfer of data along with the hardware. So that's what the difference is, again, within the field of engineering. So everything is data. For example, what we are taking, what you are seeing, this YouTube is again coming from a cloud, right? So that cloud will be stored in some of the location in a hard copy. So everything is data. For example, you and I are also a data. We have our personal own personalities, a unique personality, unique fingerprint. So that is also a data. Everything is data. Then what about the energy? Based on whatever the data it is, the energy is produced. For example, nuclear fusion or nuclear fission. So there is a data. There is a chemical. There is a nuclear equation for that. So this atom, when splitted into a so and so parts, so and so energy will be released. That's nothing but a data. That's nothing but an information. So information and energy are like two faces of a coin. How the information is, so the energy is. If there is no information, there is no energy. Simple. So data is the fundamental. What I'm telling today is data or jnana. That is a fundamental basics, because every particle, everything behave accordingly, and the energy produced it also is accordingly. So how about the different domains then? Different domain process data in a different way according to their own nature, according to their own application. Yeah, and how is when this data come? As soon as there is a originated of universe, when the universe born was created, or when the universe was originated, all the data were packed into a single point called a singularity. When the universe expanded, those data also expanded, and that existing data is the only which we are using. So that's what I'm trying to tell here. But in today's life, we also have to take about the economy. So everything has become business here. So whatever the data we use, that has become a business here. So what are business based on? They are based on karma. For example, in a very very brief and nutshell, if you have completed any education or any graduation, for example, if a person has completed graduation and working in a so and so company, he has waited some of the years to learn, to do something, to learn, or whatever it is. So need not be graduation, he has taken some time to learn those things, and again he has cleared the interview in a company to work in that. So there are two parameters, right? The past, where we have acquired the required skills, and the present, where we have cleared the interview, we have given a good interview, and then the output is getting a job. So the output depends on both present and the past input. So that's what the karma is. But karma dates back to more previous lives also. That's a different thing. So in a nutshell, what we do, we get that. If we do good, then we get good as output at the right time, given by a person who is above all. Okay, fine. So what about the spirituality then? In a nutshell, there is the experience of eternal purest divine information without using material means. We cannot, for example, information is not any physical thing, right? It can be shown as in a physical thing, but information itself is not a physical, right? Whatever the data which we write on the book is nothing but ink on a paper. Whatever data I have typed here is nothing but an electron giving out energy in a specific frequency where our eyes catches. But the information is something which has embedded on the particular photon or electron or whatever. So information, in my opinion, that is not a physical thing. So spirituality is experience of those information, but information must be pure, right? So purest information, that is nothing but the information on God, on the paraBrahman. So that is information experienced by a life or a consciousness or a souls. So that is nothing but spirituality or adhyatma. So for that, what should we do? We should configure our mind. A mind is like an API or application programming interface where we interact with the database, or where we interact. That is an interface, as the name suggests. So we have to configure ourselves first, and we have to calibrate our body first, so that we have a good receiver to receive that information which is already in the space, or ether, or whatever it is called, so that we should not get any wrong, or we should not fall into any false notion. So who is the controller? Who is the source of everything then? That is Lord Vishnu. I call him by name Lord Vishnu, who is the paraBrahman as stated in Bhagavad Gita, Vedas and everything, who is known by everything. So that is the Lord Vishnu, who is the source and controller of all. So I bow down to him and end this session. Jai Vishnu. Thank you very much.